Hey there, CodeBear here. Get ready for another exciting journey into the world of web development. Today, we're going to deploy our own Linux web server hosted in the cloud using Vultr. Before we dive in, let me introduce you to Vultr, my favorite cloud hosting provider. With Vultr, you get lightning-fast SSD drives, scalable infrastructure, and a global network with locations all over the world. While you don't have to use Vultr to follow along with this tutorial, I'm providing an affiliate link in the video description below. If you click on that link to sign up, it helps the channel out, and you'll also receive a $100 credit to try out any Vultr service you would like. That means you can follow along with this tutorial exactly, and it won't cost you anything. Pretty cool, right? At the core of every web server, we need to run a service that will allow us to serve our web pages. The most popular Linux-based web services that you can run are Apache, Nginx, and Lightspeed. Today, we're going to focus on Apache since it's one of the more simple configurations and it's been around the longest. However, Apache isn't necessarily the best option for every use case. As you learn more about web development, you should choose a server environment that best suits your project needs. So let's get to it. Since we are going to go with Apache today, we'll be setting up what's called the LAMP stack. LAMP stands for Linux, Apache, MySQL, and PHP. As a beginner, it can be overwhelming to understand all the components of web development, especially when it comes to configuring a server. While there are one-click setup options we can work with to get our server set up, I think it's important for you to understand how web servers actually work. This way, you'll be better equipped to customize or troubleshoot your servers if you ever need to in the future. To get started, go to vultr.com and create an account if you don't already have one. As I mentioned earlier, Vultr is my preferred service provider, but feel free to use any other provider if you don't want to use Vultr. Also, if you have Linux installed on your computer locally, you can still follow along with this tutorial for setting up your local development environment. After you've created an account, click on the blue Add button in the upper right-hand corner of the dashboard and select Deploy New Server from the drop-down menu. Choose Cloud Compute as the server type. Under CPU and storage technology, I suggest Intel High Frequency. This will provide you with faster processing speeds and improved performance for CPU-intensive workloads. This is an option that is also ideal for web development and running applications that require high computing power. Choose the server location you want from the list of options. Vultr offers data centers in various locations around the world, so select the one that is closest to your target audience. Your audience isn't necessarily in the same location as where you live, so keep that in mind. If you don't have an intended audience, or you're configuring a development server like I am, choose a location closest to you. For me, I'm going to choose Toronto. Navigate to the Operating System tab in the Server Image menu, and then select the Ubuntu icon. From the drop-down menu that appears, choose Ubuntu 22.04 LTS x64, or select the latest LTS version of Ubuntu. You can choose a different Linux operating system if you have a preference, but keep in mind if you choose a non-Debian-based distribution, the installation process might look a little different. Under the server size menu, we'll choose the 32GB NVMe option. This isn't a production server, so I'm just choosing the smallest option. But if you intend to set up the server for production, I would recommend choosing an option with a little more memory. For the purpose of this tutorial, we'll also disable auto backups since I intend to remove the server after recording this. But for 99% of you watching this video, I highly recommend you leave auto backups on. If something ever goes wrong with your server, you're going to be very thankful you enabled these backups. You can leave the additional features option at their default settings, but you may want to disable IPv6 if you don't intend on using it in your server. You can always add these additional features in at a later time. We're also going to skip SSH keys and Firewall group for now. To assign a hostname to your server, enter a unique name in the hostname field. This name should be something that easily identifies your server. You will see this name in your console when you remote into the machine. In this example, I'll be using the hostname CodeBearVM. To assign a label to your server, enter a descriptive name in the server label field. This label should be something that helps you easily identify your server in the Vultr dashboard. I'm going to use the label CodeBearLAMP stack. Once you've configured all the necessary settings, click on the Deploy Now button to start creating your new virtual machine. This can take a few minutes to deploy. While we wait, why not show some love and hit that like and subscribe button below. It helps support the channel and keeps me motivated to stay out of hibernation mode. If you've been following along with this tutorial so far, then congrats! You now have a cloud server deployed. Don't get too excited though, we still need to set this thing up as a web server. Right now, all we have is an installation of Ubuntu at this point. The bare necessities, if you will. No? Nothing? Alright. To establish a connection with your virtual machine, launch your SSH client such as PuTTY for Windows or Terminal for Mac OS. If you don't want to leave the browser or install anything on Windows, you can also use the web console in the Vultr dashboard to connect to your server. Back in the terminal, type in the following command: ssh root @ and then paste in the IP address of your server, then hit enter. A prompt will appear asking for confirmation from the user whether or not they want to proceed with the connection. This prompt is displayed when the client tries to connect to a remote server that it hasn't connected to before. Type yes to proceed. We now want to paste in the root password. To locate the root password, return back to the web browser and navigate to the detailed list for the server. Once you have found the password, copy it to your clipboard. Then switch back to your SSH client terminal and paste the password into the prompt. Now that we're logged into the server, let's make sure that everything is up to date. To run updates, we'll first type in apt update followed by the enter key. This will update the list of available packages from the Ubuntu repositories. After the update process is complete, type apt upgrade followed by the enter key. This will actually find and install any packages that are out of date. It's good practice to always make sure that your server is up to date before installing anything else, so make sure that this is always the first step you take, regardless of whatever you're using the server for, or how you plan to configure it. Okay, so let's get some packages installed. Run apt install Apache 2 to get the Apache service installed. Anytime you try to install a package in Linux, you'll be prompted whether or not you want to continue with the installation. Press Y to continue the install. After installation of a new package, a prompt saying daemons using outdated libraries might appear. If an installation affects a service, you may see this pop up. You can navigate up or down and press the spacebar to toggle on or off the list of services you want to restart. You can always press the Tab key and select the OK button and press Enter, or simply press Enter right away to continue with the default options. Nice. Apache should now be installed. Run the following command to verify if Apache 2 web server is running. This will display information about the Apache service, including whether or not it's running, or any errors that may have occurred. I didn't show it here, but you can also use service Apache 2 status as an alternative alias for the system control command. Another way to test if Apache is running is by opening up the web browser and entering your VM's public IP address in the navigation bar. Then press Enter to load the page. When accessing the web server from a browser, you may face a connection issue. To troubleshoot this, the first thing you'll want to check if you've already confirmed that the Apache service is running is by checking your firewall settings. On Ubuntu, we can run the command ufw status in the terminal to check if UFW is enabled. If it is enabled, we need to disable it by using the following command. By disabling UFW, you've removed the firewall that was blocking incoming traffic on port 80, which is needed to allow us to connect to our web server. Don't worry, we're not going to leave the firewall off. Near the end of this video, we'll revisit the firewall configuration to make sure that the server is secure. Now let's go back to our browser and re-enter our public IP address assigned to our VM, or refresh the tab if you left this open. Whoops, make sure you only type that IP address in one time. Looks like our web server is working. When it comes to installing a database on our server, we have a couple options to choose from. In our case, we can either choose MySQL or MariaDB. MariaDB is a community-developed fork of MySQL that serves as a drop-in replacement for MySQL. One of its main advantages is improved performance due to enhancements in the query optimizer, resulting in faster query execution times. Additionally, MariaDB offers support for new storage engines, which are designed to improve performance and scalability for large databases. I'm going to proceed with MariaDB, so let's run the command to get that installed. Great! We now successfully installed MariaDB. However, it's important to configure and secure it. We're going to run the command mysql_secure_installation, which will launch the configuration wizard in the terminal. You likely haven't set a root password yet since this is your first time installing MySQL, so just press enter here. Keep in mind the root MySQL password is different than the root server login. We're going to press N for no when we're asked if we want to switch to a Unix socket authentication. It will ask you if you want to change the root password. Make sure you don't lose this one. Next, it will ask you if you want to remove the anonymous user. Press Y for yes. We also want to disallow root login remotely. Let's also remove the test database and access to it. For the changes to go into effect, we need to reload the privilege tables. Awesome! We now have a secured installation of MySQL running on our VM. Let's confirm that we can interact with MySQL to ensure that everything is functioning properly. Log in using mysql-u root-p. If you see MariaDB or MySQL at the beginning of the command line, you are now logged into the MySQL service. Type quit semicolon to exit out of MySQL. It's now time to install PHP and its modules. Execute the following command in your terminal to proceed. Restart Apache to load the new PHP module by running the following command. We can verify that PHP is installed correctly by running php-v. This will display the current version of PHP installed on your system, which in our case is PHP 8.1.2. Now that we have downloaded and installed all the components of our LAMP stack, it's time to test our installation. We're going to create a PHP info file for this purpose. To create the file, we're going to use the nano editor along with a path to our file. var www.html is the base path to our web server, and the info.php is the name of the file we're going to create. If you specify a file that doesn't exist like we just did, Nano will create it for us as an empty file. In the Nano text editor, add the following line. Save the file by pressing Ctrl plus the letter O, followed by Ctrl plus the letter X to exit the Nano editor. Now open up your web browser and enter the following URL. If PHP is properly installed and configured, you'll be able to view the page that provides detailed information about your PHP configuration. Congrats! You've now successfully installed the LAMP stack on your Ubuntu VM. You can now use this platform to host dynamic web applications and websites. I forgot to show this in the recording, but don't forget to delete the info.php file after you confirm PHP is installed. We don't want to leave all of our PHP details exposed to the internet, since this can potentially be a security risk. Type rm followed by the absolute path of our file to delete it. Next, let's install phpMyAdmin so we can manage MySQL from the browser. During the installation process, you'll be prompted to choose a web server. Select Apache 2 by pressing space, then tab, and finally enter. You may be required to set a password for the phpMyAdmin user. You can allow the script to generate this for you, since you'll never actually log in with this user. Alright, so let's test this out. Navigate to phpMyAdmin from the browser and log in with our root MySQL credentials we created earlier. Once you are logged in, you'll have full access to the graphical interface of phpMyAdmin. From here, you can manage your databases and perform tasks efficiently without the need of accessing MySQL from the console. Using phpMyAdmin simplifies the database management process, making it accessible for users who prefer a visual interface rather than executing commands directly. It is an essential tool for developers, system administrators, and anybody working with databases. Before we conclude this tutorial, let's revisit the firewall configuration. While we could use UFW, it's better to configure this in Vultr. If we make any mistakes, we won't get locked out of our server, and we also have the added benefit of creating firewall rules that can be applied to multiple server instances if we wanted to. We're going to enable only the required ports, such as ICMP, HTTP, HTTPS, and SSH, while blocking all other ports by default. Depending on your intended usage of the server, you may need to expose additional ports. However, for this tutorial, enabling these 4 ports is sufficient. To achieve this, access the Vultr dashboard and navigate to your VM. Go to the Settings tab and select Firewall from the Settings menu. Click on Manage and create a new firewall group. Provide a description for the firewall group and click on Add Firewall Group. Configure the firewall settings for IPv4 and IPv6 if you enabled it during setup. SSH will be the default value. Click on the plus sign button in the Action column to add it as a rule. Next, choose ICMP from the Protocol drop-down menu and add it to allow ICMP traffic by clicking the plus sign button under the Action column. This will allow us to ping our server if needed. Select HTTP from the Protocol drop-down menu, which will open up port 80. Lastly, add the HTTPS protocol with the port value of 443. We will want this exposed if we want to add an SSL certificate to any of our websites in the future. Mirror these settings for IPv6 protocol if needed for your configuration. Return to the VM dashboard in Vultr. Under the Settings tab, select the firewall group you created from the Firewall drop-down menu. Click the Update Firewall Group button to apply these changes. By configuring the firewall settings to allow access to these ports, all incoming traffic trying to access services configured to use them will be allowed in, while blocking traffic on all other ports. Please note, any changes made to the firewall can take a few minutes before going into effect. And that's it! Your virtual machine server is now configured and secured. Give yourself a big bear hug and let's hope no hackers come pawing at your server door. Remember, keep your claws sharp and your server firewall even sharper. We've reached the end of today's tutorial. I hope this guide made setting up your Linux web server a breeze. If you ever get stuck, don't hesitate to reach out to the CodeBear community in the comments section below. Also, don't forget to show some love by hitting that like and subscribe button for more helpful tutorials. As always, keep coding and stay positive.